Let's tune the telescope into galaxies being born, and oh my gosh, who ordered this? We're finding we look out into the universe, and 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, galaxies, planets, comets, black holes, dark clouds, everything out there that we can see, touch, smell, or taste, and it still doesn't account for the gravity we observe in the universe. This is the longest-standing unsolved problem in modern astrophysics. When we talk about dark matter and dark energy, there's a lot we don't know compared to what we do know. What we do know is that there's a strange force that pulls galaxies closer and keeps them together, while dark energy is causing the universe to expand faster. Despite these forces, we haven't yet found the mysterious particles that explain them. Now, some scientists not only believe but have also proven that dark matter doesn't exist. Famous American science communicator and astrophysicist Neil deGrasse Tyson has announced that dark matter is just an illusion, but what proves that dark matter doesn't exist? Let's find out. If physicists were to compile a list of their most sought-after phenomena, dark matter would indisputably top the list. Dark matter is a hypothetical substance that remains unseen yet is theorized to permeate the cosmos. Only 5% of the universe consists of ordinary matter, while dark energy makes up 68%, leaving 27% for dark matter. Dark matter and dark energy are opposing forces that coexist within the cosmos. Dark matter exerts gravitational pull, while dark energy acts as a repulsive force. These theoretical particles make up 96% of the universe, yet they remain invisible, having no interaction with light, neither emitting, absorbing, nor reflecting it because they are disconnected from electromagnetic forces. So, if dark matter cannot be observed, how do scientists know it exists? Dark matter is simply what we call this unknown entity responsible for 85% of the gravity in the cosmos. We've known about dark matter since the 1930s, when it was referred to as missing mass because gravity and mass must coexist. The sole clue to dark matter's existence lies in the gravitational effects it exerts on celestial bodies like stars and galaxies. It's akin to an invisible wind that moves tree leaves. We perceive the wind's presence through its effect on the leaves, even though we can't see it. NASA has observed star clusters with gravitational forces that exceed what visible matter can account for, leading them to assert that dark matter must be at play. The concept of dark matter isn't new. It first emerged in the 1930s when astronomer Fritz Zwicky noticed distant galaxies in the Coma cluster moving too fast to remain intact, leading him to hypothesize the existence of an unseen substance holding them together. In the 1970s, astronomer Vera Rubin made a similar discovery, finding that stars in spiral galaxies were moving faster than expected, implying an unseen force, possibly the gravitational pull of dark matter, was keeping those galaxies intact. Although various particles have been proposed to explain dark matter, experiments so far have not provided concrete answers. A recent study challenges dark matter's existence, suggesting that our limited understanding of gravity may explain the gravitational forces observed in galaxies rather than the presence of dark matter. Scientists have also discovered a galaxy, AGC 114905, which shows no signs of dark matter. An international team of astronomers studied the galaxy for 40 hours using advanced telescopes and found that its gas movements could be explained by regular matter alone. Though dark matter theories predict its presence in AGC 114905, no such matter was observed. Possible explanations include the idea that a nearby galaxy stripped away the dark matter, but no nearby galaxies were detected. Another theory involves the angle at which the galaxy was observed. Meanwhile, new theories are being proposed to explain these observations. Scientists are also trying to detect gravitational waves and ripples in spacetime to uncover more about dark matter through tools like the Laser Interferometer Gravitational Wave Observatory and other advanced detectors. Gravitational waves billions of light-years away may potentially help locate boson clouds. Boson clouds consist of extremely light subatomic particles that are incredibly hard to detect and have been proposed as a plausible source of dark matter. Researchers hope to track down these particles by searching for gravitational waves caused by boson clouds swirling around rapidly spinning black holes. If these particles exist, they possess an extremely tiny mass and rarely interact with other matter, aligning with one of the key properties of dark matter. By searching for these elusive clouds, we may be able to uncover the secrets of dark matter. However, dark matter, one of the most puzzling substances in the universe, has recently become even more enigmatic. A recent study suggests that dark matter may originate from regular matter. According to an older theory called freeze-out, dark matter formed in the early universe when all particles were tightly packed in a hot, dense mixture known as the thermal bath. Initially, most of these particles existed as dark matter, but they were annihilated upon interacting with regular matter, a process known as annihilation in cosmology. In contrast, a reverse scenario where dark matter replaces more abundant regular matter in the early universe is called freeze-in. Researchers once believed that regular matter outweighed dark matter, but this perspective changed with a new model. In this model, when a particle of dark matter collides with another, it annihilates and produces two dark matter particles. This resembles how positrons and electrons annihilate each other to generate photons. The critical distinction is that this model results in dark matter production at an exponential rate. If true, it explains the current dark matter to regular matter ratio of 6:1. However, a major question arises: if dark matter continuously converts everything else into more dark matter, does this mean the universe will become a massive dark matter entity? If the process continued too long, dark matter would dominate, but this mechanism only operates under high temperatures, such as those in the early universe. As the universe cooled, the reaction ceased, fixing the amount of dark matter. Where does dark matter fit in? Dark energy wasn't discovered until 1998 when observations revealed that the universe's expansion was accelerating. To explain this, astrophysicists introduced dark energy, which permeates all of space, possessing negative pressure that inflates the cosmos. It interacts minimally with gravity. In 2020, scientists at the Xenon 1T facility made an intriguing discovery. Their dark matter detectors picked up an unusual signal, suggesting new physics. They speculated that the detector might have detected dark energy, not dark matter. The experiment involved a large tank filled with liquid xenon placed underground to minimize interference. Sensors were set to detect light flashes and electrons released when a dark matter particle passed through. However, an excess of 53 events above the expected background level hinted at something strange. While the leading candidate was a hypothetical particle called a solar axion, which would be produced by the sun, it became clear that the number of actions needed to explain the signal was too high. This led scientists to suggest a new suspect, a particle that acts as a carrier for dark energy. Some astronomers remained skeptical, but if true, it would be a remarkable breakthrough. Directly detecting dark matter or dark energy would rank among the greatest discoveries in history. Neil deGrasse Tyson, a well-known American astrophysicist, believes that dark matter may not be matter in the conventional sense, but an unknown force or phenomenon. This misconception arises from the name dark matter. Tyson suggests alternative names, like dark gravity, to reflect its gravitational effects on other objects. He also humorously proposes Fred as a placeholder name devoid of meaning. Now, let's discuss how the James Webb Space Telescope, JWST, could help reveal dark matter's mysteries. Equipped with advanced technology, the JWST can map dark matter distribution on a cosmic scale through its gravitational effects on visible matter. It can also study dark matter in dwarf galaxies, where dark matter is expected to dominate. By observing star and planet formation in dark matter-dominated regions, the JWST could provide crucial data on how dark matter influences the universe's development. The telescope's observations can provide valuable insights to test and refine theoretical predictions regarding dark matter's particle nature. These observations may also help identify potential signs of dark matter annihilation or decay, supporting the search for direct experimental evidence both on Earth and in space-based detectors. In 2023, several missions are underway or planned by NASA and other space agencies to unravel the mysteries of dark matter. These missions employ advanced technologies and innovative approaches to explore the nature, distribution, and properties of this enigmatic substance. Euclid, led by the European Space Agency, ESA, was launched on July 1, 2023. This mission aims to investigate dark matter and dark energy by mapping the three-dimensional distribution of galaxies and galaxy clusters. Euclid seeks to uncover more about two of the universe's greatest mysteries, dark energy and dark matter. By observing the weak gravitational lensing effects caused by dark matter, Euclid will provide valuable insights into its distribution and influence on cosmic structures. ESPER-X, a NASA mission currently in development and set to launch in 2025, will contribute to our understanding of dark matter. Its primary focus is on the origins of the universe and galaxy formation. ESPER-X will map large-scale structures and study thousands of galaxies, offering valuable data on the cosmic web and dark matter's role. Athena, an X-ray observatory led by ESA, is planned for launch in the coming years. It aims to study various astrophysical phenomena, including the connection between dark matter and galaxy clusters. Athena will observe X-rays emitted by hot gas within galaxy clusters, helping scientists investigate dark matter's influence on their formation and evolution. The Nancy Grace Roman Space Telescope, formerly known as WFIRST, another NASA mission set to launch soon, will significantly contribute to dark matter research. While its primary focus is on dark energy and exoplanets, the Roman telescope will also map dark matter's distribution and probe its influence on cosmic structures through large-scale surveys and weak gravitational lensing. Dark matter remains an enigma, and its elusive nature makes it one of the most intriguing challenges in physics. As scientists continue their research, more clues will come to light that help unravel the secrets of the universe's hidden forces.